All right, let's talk about some testing that can be done to look at lung volumes and capacity. So lung volumes are not the same for everybody. They decrease as you get elderly. They're smaller for typically women than for men. Obviously, if you have a smaller body size, they're going to be smaller, especially if you have a lower height. And here's an example of various lung volumes that a tracing that would be done and the words. So let's go through this one by one so you understand. And then when you're done, you can come back and you will know what all these words mean. So to measure lung volumes, basically, you would be hooked up to a breathing machine and a tracing would be done. And so what I want you to realize, when you inhale, the tracing goes up, and when you exhale, it goes down. So just do normal breathing. Inhale and exhale. Inhale and exhale. Inhale and exhale. All right. So we're just normally breathing in and out, and we'll have a curve going up and down and up and down. And then, besides our normal breathing at rest, our passive inhalation and exhalation, we know, okay, so we could have some passive inhalation, exhalation, inhalation, exhalation, but we know that if we want to, we can take a really deep breath. So everybody do. Okay, and now I want you to blow it out, blow, 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 blow out as much as you can, and then just go back to regular breathing. Okay, so now we have a breathing curve we can look at, and I'm going to talk about what these different curves are called and give you an idea of what normal volumes would be. Okay, so the normal breathing in and out, the passive inhalation and exhalation, that normal volume of air with normal breathing at rest is known as your tidal volume. Think of it as the tide going in and out, and in and out. And the amount of air that you normally breathe is the equivalent of a normal bottle of water, 500 milliliters. Okay, so it'd be about twice the size of this one. It would be this size bottle. That's how much air a normal adult breathes in and out, whereas a child would breathe in and out about that much air at rest. Okay. So then I ask you to take a deep inhalation. Inhale as much as you can. All right. So we have what's called the inspiratory reserve volume. So it's not everything you can inhale. It's after a normal inspiration. The extra air that you can inhale when you inhale as much as possible. That's the inspiratory reserve volume. And notice that's about an extra 3 liters. So like 6 more bottles of this. Okay. So there's a huge reserve that you can inhale, and that's what athletes take advantage of, because when they're competing, they're not doing normal tidal volumes. Their tidal volumes during competition have grown to be more than a liter or a liter and a half with every breath. Okay. Then I ask you to exhale as much as you can, and this would be the expiratory reserve volume. So once again, after a normal exhalation, the extra air you can exhale when you exhale as much as possible. And notice this is only about an extra liter. Okay, so we don't have a whole bunch of extra air left in our lungs. We don't have 3 liters of extra air in our lungs that we can exhale. Okay, and so if you don't believe doing it this way after the extra inhalation, do it that way, you can just do a normal inhalation, like just do normal tidal volumes in and out and in and out, and then blow out without doing the huge inhalation. Just do a normal inhalation, normal exhalation, and then do a big exhalation, and you'll notice that you can get that extra liter plus of air out. So you do have that extra reserve volume. But notice on both of these, it's showing that there is still air, and that is known as your residual volume. In other words, remember our friend surfactant, which kept our alveoli from collapsing down? Yeah, so we do have a residual amount of air in our alveoli. Plus, we have all that dead space in our conducting system. We have all that air in our bronchioles and our bronchi and in our trachea that is just left there afterwards. So all that air that's left after your maximal expiratory effort, there's always at least a liter. Okay, so this is showing 1.2 liters left in your airways and your lungs after you have your maximal expiratory effort. So those are your volumes. Now, with your volumes, we can determine lung capacity. So volumes are things we actually measure. Okay, yes, residual volumes is calculated based on your height, your weight, your age, and all that kind of stuff. But based on your volumes, we can add them together to get capacity. And there's two capacities we're going to learn about. And the first one is called the vital capacity because it's the important one for life. It is vital. Okay. So where it starts is up here at the top. After taking that maximum inhalation, it is this total amount of air that you can exhale when you exhale as much as possible. And why is this vital? It's okay, so look and see what it is. It includes your inspiratory reserve, it includes your tidal volume, and your expiratory reserve. So what does that air mean? What it is, it's all of the air that was available for gas exchange. Okay. And this, depending on your size and your sex, is going to be about 4.5 or 5 liters. So this is the maximum amount of air that you could exchange at any one time. And then the other capacity would be your total lung capacity, which is after a maximum inhalation. So go all the way up here. It's the total amount of air found in your lungs, which is going to be about 6 liters because all we're doing is taking your vital capacity and adding the residual volume to it. All right, that's it. Come on back for our next topic, which is going to have to do with gas exchange and controlling ventilation. And I'll see you shortly.